Okay, I wanted to tie in to the toothpick problem we did last week. I wanted to tie in slope change and initial amount, which is the Y-intercept. I wanted to tie those two ideas to the pattern in many different ways. Okay, just real briefly, the toothpick pattern, this was step 1 with 5 toothpicks. Step 2 had 9 toothpicks. Step 3 had 13 toothpicks. Okay, a couple things we noticed on Friday or Thursday. The toothpicks are increasing by 4 every time. And you guys came up with some really good rules that would give you the number of toothpicks for any step. Okay, a bunch of them. Maybe the easiest one was to know that you started with 1 toothpick. And if I wanted to know like the 1,000th step, I could think of it as that 1 toothpick plus 1,000 groups of 4 additional toothpicks, because each step adds 4 more toothpicks. So one of the rules was take 4 times the step, okay, to get all of the groups of additional 4 toothpicks added to the initial 1 toothpick right there. Okay, so let's go to the second slide. The video is just over the second slide. So we were looking at the data in a data table. Step 1 had 5 toothpicks, step 2 had 9, step 3 had 13. If you keep adding 4, you have 17, and 21 for step 5. Okay, one of the rules was we take 4 times the step and add 1. So step 10, 4 times 10 is 40, add 1, that would have to be 41. For step 100, we could take 4 times 100, okay, 400, and add 1. So that's 401. Okay, something else that's going to help us with this slide is knowing step 0, the initial amount at step 0. Okay, just notice the pattern going up the data table here. 17, 13, 9, 5. Okay, do you notice that it's going down 4 as we go up the data table? So if it keeps decreasing by 4 as we're going up, we have to take 5 minus 4 to get 1. Okay, so here's the data table of the relationship. And let's go ahead and graph the data table. And then we're going to go crazy with this. Okay, we're going to show at step 0. If there was a step 0, it would be 1 toothpick. I'm going to zoom this down to 25 so we can see what we're doing better. You may have to do that too. Okay, step 1 is 5 toothpicks. So I'm going to put a dot at 1, 5. Okay, step 2 is 9 toothpicks. I'm putting a point at 2, 9. So I'm just looking at the data on my data table and graphing points. Okay, at step 3, we had 13. And at step 4, we had 17. Okay, and maybe you've already noticed this is a straight line. This is a straight line. I'm going to drag that line over. Get in the right spot there. Okay. So we have the graph, we have the data table. Let's take a look at the rule again. We said for any step, one rule, maybe the easiest rule, was that we could take 4 times the step x and add 1. So the rule would be take 4 times the step x, 4x, add 1. Okay, here's a statement that kind of ties it together. The total toothpicks, y, equals 4 times the step x plus 1 more. Okay, so I could write an equation. It's just knowing that y is the toothpicks. Okay, so my total toothpicks, y, okay, I'm going to type in y, is equal to 4 times the step plus 1. And guys, I'm throwing a lot at you all at once. We're going to keep coming back. I'm just trying to give you the great big picture. Okay, the great big picture, and then we'll look at the individual pieces as we go along. Okay, but what I want to do, I want to take this relationship and I want to look at everything that has to do with change. All these pieces are up above your slide or beside it. I'm going to think of all the things that are changed. So I'm going to bring that blue highlighter down over change, because there's a bunch of pieces to this relationship that have to do with change, which is slope. And there's bunches of stuff on this relationship that has to do with initial amount, which is called the Y-intercept. So if you could whenever I drag things down, if you could just do the same thing, because I want you to see it. Okay, there's slope and initial amount everywhere in this picture. Okay, let's just do slope. Okay, let's look at slope everywhere we can. Okay, slope on a graph, okay, is rise over run. So I have a blue image that shows we're going up 4 toothpicks over 1 step. Up 4 toothpicks over 1 step. So it's increasing 4 toothpicks per step. Okay, so that's change. The change in the data table, okay, slope is change. You guys know a data table, the slope is y change over x change. Well, if you drag this piece right here where it says +4, it's kind of connected to another piece. But if you drag that down, okay, this is showing you that the change on the data table is that the y's are going up by 4 toothpicks. Okay, that's the y change, as the x values are going up by 1 step. Okay, so it's showing you're going up 4 toothpicks per step. Okay, that's the change in the data table. Okay, the change in the rule, you don't know this yet, but the change will always be sitting in front of the x. Okay, in the rule, that 4 is the change, and in the equation, the number in front of x will always be the slope. Okay, we'll get into more detail with everything soon, okay? In my statement here, that 4 times the step is showing the slope, the change. With my toothpicks, okay, think about what the toothpicks were doing. They were increasing 4 every time. So I wanted you to see that the last 4 toothpicks of any step could be considered the change, because we're always adding 4 more toothpicks to the end of the picture. Okay, so we have change, the slope, all over the place. Okay, within this relationship. Okay, everything else in this relationship, it has to do with the initial amount. Okay, the initial amount of toothpicks. Okay, so this is brand new to you. Okay, when you look at the graph, the initial amount of toothpicks, and when I say initial, I mean at step 0. Step 0. Okay, at the 0 step, if I want to know how many toothpicks at the step 0 in my toothpicks, looking at the graph, notice right here, it says step 0, and there's a 1 toothpick. Okay, that point is the initial amount. Okay, it's always where the initial amount will always be where your graph crosses this y-axis. It will always be, that initial amount will always be where that graph crosses this y-axis. And there's a special name for that. You can drag this big text box down. Okay, that's called a Y-intercept. Y-intercept. Intercept means cross. Okay, the Y-intercept of a graph is where the y-axis is crossed. Okay, so that Y-intercept, where the graph crosses the y-axis, shows us the initial amount. Okay, the initial amount on a data table, look right here, step 0, 1 toothpick. Okay, that shows the initial amount at step 0. So I'm highlighting everything red that has to do with initial amount. Okay, and I'm going to drag this image down above the other text box, the smaller one, because when you have a data table, the initial amount is always going to be the number across from 0. Okay, so the red stuff's brand new. Okay, it's new to you. You've done slope quite a bit, but you've never done this initial amount before. Okay, and on the left side of the slide, in my rule, the initial amount, or y-intercept, is always after the slope and the variable x. We're using x for today anyway. Okay, so the y-intercept is after the slope and the x. Same with the equation. The initial amount is after the slope and the x. There's my positive 1. In my statement, where I'm talking about the plus 1 more, okay, well, that plus 1 more toothpick was the toothpick we started with at the beginning. To find your answer, you always had to add that 1 toothpick at the very beginning. Okay, in your picture, the y-intercept, or the initial amount, is going to be the toothpick right there, the one that would be considered step 0. Okay, this is crazy. Lots of information. Okay, but I'm trying to give you the great big picture at the beginning, and then we'll back up and back out of this as much as we need to. But just notice, the slope is everywhere. Slope is change. Okay, in a graph, the change is up 4 toothpicks over 1, rise over run. The slope in a data table is change in y over change in x. It's showing it's going up 4 toothpicks for every step. The slope or change is always in front of the x in your rule or in your equation. Okay, the initial amount is everywhere. The initial amount, we call that the y-intercept. Okay, the initial amount is going to be where it crosses, where your graph crosses the y-axis when you're looking at the graph. Your initial amount is always going to be across from 0, whatever number is across from 0 in your data table. And the initial amount will always be at the end of your equation. Okay, big picture, just do your best. And again, we're going to keep backing out of this as we need to. Let me know if you have any questions.